Greetings and welcome back. Today we'll be looking at how to name alkynes, which are the molecules that have a C triple bond C somewhere in them. We will first talk about how to name alkanes when they're the only functional group, and then we will move into how do we name molecules that have both an alkyne and an alcohol, or both an alkyne and an alkene. The naming of alkynes when they're the only functional group in the molecule is both simple and also very similar to how we named alkenes. So, for instance, this molecule right here has 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. And don't forget that these are carbons right here. The reason that we draw these out straight, so off to the sides we'll often have the bond sticking straight out, is because these carbons are sp, and therefore they form bonds that are 180 degrees, and so this should be straight with both the single bonds and the triple bond, and then the single bond after that. So remember that those are C's, so we can number this out. We would want to number this from the left because that way you would get to the alkyne more quickly. 3, 4, 5, 6, 7, 8, and 9. So the way that we name an alkyne is to replace the ane at the end of an alkane with ine, the same way that we did with ene to make alkenes. And so therefore the name of this molecule would be a nonane, but it has an alkyne, so it would simply be nonine. And we do need to indicate where that triple bond is found, and just like we did with alkenes, we put the number corresponding to the first carbon that contains the alkyne. So because it's from 4 to 5, we would just say that this is 4-nonine. And the assumption is that you know that the alkyne would go from carbon 4 to carbon 5. The other way to do this, just like with alkenes, is to do non for ine. And that's it. That's how you name alkynes. And I don't have much spicy to add to that. There are no E's and Z's associated with this because, once again, these bond angles are 180 degrees. And so it's always going to be exactly linear, and so we never have to worry about stereochemistry when it comes to alkynes. So that's it. Let's try it, and then we'll move on to how to deal with molecules that have multiple functional groups, including an alkyne. To revisit our priority in terms of functional groups, and this includes how you choose the main chain and how you number the main chain. The first one so far that we've done is alcohols. And then we had alkenes. And this is still true that this is our second highest priority. And then we have alkynes. So alkynes actually come right after alkenes. So if you want to remember it, these go in alphabetical order. In general, what we'll find with these priorities is that they're ranked according to the number of bonds to heteroatoms. Again, heteroatoms means things besides carbon, so oxygen or nitrogen. Because alcohols are carbons with one bond to an oxygen, that beats molecules with 2 bonds just between carbons or 3 bonds just between carbons. And as we move into it, the number 1 at the end of the day is going to be carboxylic acids because that's a carbon with 3 bonds to oxygen. It has a double bond O and a single bond O. So keep that in mind when we're going through the priority. That's always the reason why these things are ranked the way that they are. All right, so let's do an example of this. What if we have a molecule that looks like this? How would we name it? Well, we need to find our main chain, and our main chain should be the longest continuous carbon chain that includes the highest priority functional group and also, if possible, the second highest priority functional group. So in this case, we can actually find a main chain that includes all of those things. So this carbon chain right here is a continuous carbon chain. The alcohol is attached to it, and the alkyne is also a part of it, so that's no problem. And when we number this, we want to number it according to the highest priority functional group. And once again, our highest priority functional group in this case would be alcohol still. So we want to number from the left because that gets us to the alcohol the fastest. 4, 5, and don't forget again that this carbon right here is still a carbon. It's a transition between a carbon-carbon single bond and a carbon-carbon triple bond, but it's still a carbon. So that's our 7 carbons. So let's go back to looking at generally what the name of an alkane is. We say alkane. The alk gets replaced with a number of carbons. The ane can become ene or ine if we need to. And the E at the end gets replaced if you have an alcohol. So because this molecule is 7 carbons, it would be hept. And then there's an ine, which starts at carbon number 6, so hect 6 ine. And then there's an alcohol at carbon number 2, so hept 6 ine 2 all. The reason we put the numbers in the middle of the names is because there's multiple functional groups. If you only have one functional group, you can put it in the middle or at the beginning, it doesn't matter. But if you have multiples, you need to put the numbers in there so we know which number corresponds to which functional group. Finally, it's always important to remember that stereochemistry can exist. If you ever see a wedge or a dash, you should consider, is this a chiral molecule? Or are there chiral carbons in there? And in this case, the answer, fortunately, for the sake of practice, is yes. So this carbon right here is chiral. And we can rank our substituents. I'm going to do it in a different color so we don't get it confused with the numbers we already put down when we were numbering the main chain. So the OH is number 1. Carbon on the right, which is a CH2 with a C attached, is number 2. The carbon on the left, which is just a C with 3 H's attached, would be number 3. And then the H is already in the back for us, and that is number 4. All right, because 1 to 2 to 3 goes clockwise, since 4 is in the back, this would be an R molecule. Therefore, we would just put the R out in front. So even though with an alkene, you can put the E or the Z right next to the alkene, well, an E or a Z is specifically talking about a single functional group. However, R's and S's don't always relate exactly to one functional group. So it appears that this R goes with the alcohol, but because you could have 2 different things at position number 2, you could have an alcohol and a methyl group, so that would be 2 different functional groups or 2 different substituents. We just put the R's and the S's right out front all the time. You can do the same thing with the E's and the Z's, so we can always just leave the R's and the S's and the E's and the Z's way out front, and we're done. So that's the name of that guy. All right, so what happens if we have both an alkene and an alkyne? Well, the same rule remains. Rule number 1 is we need to find the longest continuous carbon chain that includes the highest priority functional group if possible, and also, if possible, the second highest and the third highest, etc., etc. So let's do this. Definitely, we need to include the alkene, but as a bonus, we can also include the alkyne. And then we want to keep going as long as we can, and therefore this would be the end of our chain. That's the longest continuous carbon chain that includes both of those guys. So let's number this. And once again, even though there's a methyl group close to the right, and even though the alkyne is close to the right, in terms of our priority, alkene wins. And so we just want to number this so that the alkene is at the closest end to where we start numbering. So the alkene is closest to the left, so we'll start on the left. 1, 2, 3, 4, 5, 6, 7, 8. So in this case, we have a molecule that in the main chain, it's an octane, or an oct is the main chain, but includes both an alkene and an alkyne. So we do something funny here, which is that we start with alkane, and we add both the ene and the ine where the ane was. So this would be an oct, ene, ine. We put them both in there. So once again, if we kind of start with the alkane, the alk becomes the oct, and then for ane we put in both ene plus ine, because they can both go in there if they're part of the main chain. So it's a little elongated, but that's okay. All right, but of course we need to include numbers and stereochemistry if possible. Therefore, we have actually oct 2 ene 5 ine. Once again, we need to consider stereochemistry. We don't have any wedges or dashes, so we don't need to worry about R or S. However, we do have an alkene, and it's always possible that you might have to do E or Z for an alkene. So in this case, because we have two different groups on the left side of the alkene and two different groups on the right side, we do indeed have to do that. So once again, we're going to switch colors, and when we do this, we draw our kind of imaginary line along here, and we rank on each side 1 and 2. So carbon beats hydrogen, so that's 1, hydrogen is 2. On the right, carbon also beats hydrogen, so that's 1 and that's 2. The ones are not together, they're not on the same side of that little dashed line, therefore they are apart, which is E for entgegen. And so we will put the E in right next to the number corresponding to the alkene. So we're almost done. We have a methyl group at carbon number 7, and so we would just say 7 methyl oct 2-ene 5-ine, and that's the name of that molecule. All right, please practice this. And if you have any questions, bring them to class. I will see you soon. Thanks.